In today's video, I want to talk about graphing systems of equations. Now, your first question might be, what's a system of equations? Graphing systems of equations. What's a system of equations? Well, a system of equations, and if we're talking about graphing a system of equations, then instead of graphing one line on our graph, well, we just graph two lines on the graph, and that makes up a system. It's more than one equation. Okay, so let's check that out. Let's see what happens if we get up a graph, and let's find two equations. I'm just going to write two equations in slope-intercept form. Y equals, I don't know, negative x minus 3. And what if we did something like, I don't know, y equals x plus 5. Why not? Okay, so negative x minus 3, let's use red to talk about that, and we'll use orange to talk about x plus 5. So negative x minus 3, we start at the y-intercept of negative 3. Negative x is a slope of negative 1 over 1. Okay, so there's our graph. Looks something like that. Okay, what about x plus 5? Well, x plus 5 would be here. And x just has a slope of 1, so that's up 1 over 1. And we'll see something interesting happens here. And this might not always happen, but for today, we'll talk about the times when it does. My two lines cross. Okay, so we've graphed the system of equations, and often you'll be asked to find the solution to that system of equations. Oops. So the solution, maybe we can get blue back out. Solution is where the lines intersect. Meaning it's where the values of x and y are the same. That doesn't mean that x equals y, it just means that for one graph, x and y are two numbers, and then for the other graph, x and y are the same number. So, for instance, in this graph, the solution would be negative 4x and 1y. So the solution would be negative 4, comma 1. Because that's the point, maybe we can make it really clear that it's right there. That's the point where my two lines cross. And the meaningful thing about this is that if we were to substitute in this point for either of these graphs, then it would give us, it would be true for both of those graphs, right? If x is negative 4 for the first graph, then y is 1. And you can kind of see that. Oops. Kind of look at that, right? Y is 1 equals negative 4 minus 3. That's positive 4 minus 3, and that is 1, right? In the same way, here x plus 5, 1 is 1 equal to negative 4 plus 5. Well, yeah, 5 minus 4 is 1, so that also works. So that's when we say we have a solution to a system of equations, that's what I'm talking about. The fact that my x and my y value are the same for both lines. Okay, I want to give you one more example, and then we'll call it for this video. What if you don't have nice lines? I don't know. What if you have something like this? Y minus y minus 2x equals 3. And we'll give ourselves the other one. 2x. Let's see. I want to give us one that's not. Okay, sure. What if we did? Okay, and what if we also had y equals 1/2 x? I don't know. Why not? So now I can graph this, y equals 1/2 x, right? That's definitely something I can graph. Starts at 0, 0, up 1/2. Right here and here. Okay, so that's something that I can definitely graph. But what about this, y minus 2x equals 3? Well, I have to get this into slope-intercept form in order to be able to graph it. So in order to do that, oops, it's kind of a nice arrow. In order to do that, if we have y minus 2x equals 3, what could I do to my equation to get that into slope-intercept form? If I add 2x to both sides, then I'm left with y equals 2x plus 3. And there you have it. It's in slope-intercept form right there. So now I can graph this, right? Go up 3. That's my y-intercept at 3. And now we have 2 as the slope, right? Up 2/1. Boom. Okay, so now where's the solution to this system of equations? What's the solution? As I get everything back in order, the solution. It's where they cross, right? So here, my solution would be -2, -1. And again, that holds true for both of these equations, right? For example, if x was -2, that would be y minus 2 times -2 is -4. So y plus 4, y is -1. -1 plus 4 is 3. In the same way here, 1/2 of -2 is -1. So that's your solution to that system of equations. So with graphing, it's just like in the past when we would graph one, except now we're graphing 2 equations and finding where they intersect. We'll talk in a later video about what happens when they don't intersect. Until then, see you next time.